To another exciting edition of the Eiffel Diaries. Today I'm going to be working on the Power Actor. It's been a while since I was last able to record a diary entry. There's been a PL hack week in between where I had little time to work on this, but I have done little bits and bobs in the evenings, so not substantial amounts of work to try and get the Power Actor finished. I can't remember if I'd started that yet or not since the last diary entry. I think I might have, which is worrying because it's been 21 days according to the PR there. So it's been open for a while. It's taken a while. There's a lot of other things that I needed to implement in order to get to a point where I could just convert the actor code to JS. So I have this PR open, currently working through it. The stage I am at the moment is I've done all the implementation. And I'm currently writing tests, copying tests from specs actors over to JS. It's been a while, but we have the code. We've got the actor code, which is there's a lot. So there are 9. Well, there's one deprecated method which I've just removed because we're never going to see it. So there's 8, I think, methods in actor for the Power Actor. This is a big file, and actually what I'm going to be fair, 300. There's 200 lines of utility function which I'm gonna probably pull out. I'm also, for larger actors like this one, I'm going to make an issue and refactor them so that each method that they export is pulled out into its own module, because these tend to be, when they're not just really small ones, they tend to be quite long and have return types and param types which take up a lot of space, and this is unwieldy as it is at the moment. So I'm probably going to refactor to just pull out those methods, which would be a departure from Go, but I think it will make it easier to work with. And we've already done that I've done that with other tests that we have already for different actors. I've pulled them out into separate files, and that's good for not only understanding, but also Ava will run them in parallel on a per file basis, so it will reduce the test time. So I've done that for the tests already. I think I'm going to have a methods folder and then just have a bunch of files in there for each method that an actor exports, or maybe just one with methods in it for the smaller actors. Anyway, not super interesting. We've got the actor. It's long. There's lots of stuff going on here. We've got state, which is also it's pretty big. It's not super big. Interesting thing in this actor with state. Where are we? So the power state, here we go. Yeah, so what I've noticed in this actor, which isn't the same in other actors, is that there are public methods, but there are also package private method, or private or package private methods. I don't know if there are private methods in Go that are just private to the struct. But maybe there are. Anyway, there are methods that are package private in Go that are being called on this class from the actor. We don't really have package private in JS in any way. We have, we can have in Typescript have public, private, protected, but not package private. So in that case, what I've done is I've actually made it public. So for the private ones, for the most part, I think for all of them actually, for private methods, I've always added an underscore and tried to label them private where possible, so that they are actually private in TypeScript's eyes. For the package private ones, I've just made so they're public by default. I've put an underscore in which is in general in JS land, it's a hint to say don't use this because it's not part of the public API. And so the actor calls, so for example, the actor calls delete claim here. So I'm not super happy about this, but and maybe this should be just a method that is exported that takes a state and operates on it. But look, this calls a private method, I think, anyway. Add to claim, is it private? Yeah, see, this is private. So yeah, this is the problem. So there's that. There's private, and there's package private. And package private are public methods, but with an underscore is the convention I've gone with. I've made a note of this in the, there's a specs actors diff. I've made a small note of it there. We can probably maybe work on that and figure out a better way. What I was thinking actually was that instead of private with underscore, to distinguish them as like properly private, I was gonna maybe make use of the hash properties and actually have like it's really private. So in JS, the hash methods are, I don't know if this works. A method cannot be named with a private identifier. So look, I'm not even sure this is going to work. But you can have private properties in classes and private methods. I'm not sure why that's not working. Maybe it's just TypeScript doesn't understand it yet, or maybe I've got it wrong. But that would distinguish it as like properly private, and then we can have protected stuff as protected with the public, but with the underscore and then we have some sort of good differentiation between things that are actually private and things that are public but private, without having to like click through to the actual code that you're calling and check. Because I believe that even though if you specify something as private in TypeScript, when it gets compiled, you don't get a it doesn't make it private in any way, but maybe it does. I don't know. Let's have a look. Power. I think I might have. Yeah, so this is public still. This is meant to be private, but it's still public. TypeScript hasn't done anything, so it's only when you're coding so it's not enforced at runtime. Whereas if we used hash properties, then I believe it is enforced, which would be kind of rad. Anyway, so I made an issue to do that. Maybe needs to work, but I also need to add an issue for actor methods. Individual modules, yes, because I haven't done this yet. Labels, yeah. Should just be easier to read bits of actor code if we did this. So let's create that issue. And I also have an issue here to so in TypeScript you have these. So I've been so often when I've been constructing classes, you'll see it in oh hang on, let's just look at the state. Yeah, so often when I've been constructing classes, I've had a constructor, takes parameters, and I've been declaring the public properties for the class, and then been setting the property here to that property. In TypeScript, there's a special syntax for doing this sort of thing, which makes it way less boilerplatey. I mean, that's a really not very boilerplatey example, but when you have loads and loads of things to set, it becomes really boilerplatey. Like this one, not this one. Yeah, maybe what was it? You can see how it gets a bit boilerplatey. So anyway, there's this syntax for it which we can use. I'm gonna maybe switch over. Let's see if I can find an example that I've used here. Yeah, so yeah, here we go. So you just put public in front of the property you want to be public, or it's, you know, whatever specifier you want. And what it will do is basically the equivalent of doing a this.id address equals ID address on the class, which means that you don't have to have separate declarations at the top, and you don't have to do a whole load of assignments in the constructor. It'll expand that stuff out for you. So that's super useful. I'm switching to doing that everywhere. I need to do it in, I think I just saw some in here where I haven't been doing that. Kind of want to do it in all of these classes. The only thing is ESLint seems to currently complain about this, so I have to put a little disable line thing, so that needs to be fixed at some point. But it's worth it for the... Oh, I haven't done it here because actually... Oh, maybe I could do it for here, couldn't I? Look. Oh, I couldn't do it here because I've actually declared them up here. So, and that's okay, because in this case, it's kind of useful to have everything declared or not. All right, so there's that. The other thing that I wanted to talk to you about was CBOR encoding again, because last time I think in the diary I was talking about how I'd figured out that when Lotus CBOR serializes, or when the CBOR gen tool CBOR serializes objects, it serializes them into arrays of stuff rather than the actual object with its property names and stuff, which is cool because it means that the property names can be don't have to be like their casing doesn't have to be a problem between implementations, so there's not going to be any conversion code, and it means that in fact the actual bytes that get put on the wire are super concise and reduced as much as possible. It's literally just the data, and the structure is just the order of the fields in the array. So it makes it difficult if you ever want to change stuff or reorder fields, but then it doesn't, I guess that doesn't matter too much for us, because if you have to do that, then you're probably going to have a network upgrade, a mandatory network upgrade, where everyone needs to upgrade at the same time anyway, so it's not too much of a problem. But anyway, I found out that any of the types that are big ints in Go actually get encoded to a byte array, not numbers in the. Because what CBOR will do is, if you've got a number, regardless, in JavaScript land at least, regardless of the size of the number, like if it's a number or if it's a big int, if you've got like the number 1 in a big int, then it will encode it as like the smallest possible like integer type that it can, because that's the whole idea, is that it's meant to be concise. So it doesn't matter what the number is. So that's really clever, but then we'd lost that ability because big ints, any types that were big ints have now become byte arrays. So that's interesting. And I found this out because in the Hack Week I was building, let me show you this Filecoin messages observer thing, and all it's doing is it's just a libp node, and it connects to the Filecoin mainnet and listens on PubSub for messages, for chain messages, the messages that are being gossiped by nodes in the Filecoin network, and it just kind of logs them out. But what I realized is that when you connect to to Bootstrap ourselves, we're connecting to a random mainnet Bootstrap node, and then what it does is the Bootstrap node sends us a kind of message over the hello protocol. And so I just logged out what the bytes of that message, and then looked at the type in Go and realized that actually what I got given on the wire, what CBOR decoded, was I got an array, but the values for big.Int types were not numbers or big ints. They were uint8 arrays. So then I realized that let's have a look. It's the message. When I was decoding these things, I got an array, and so this is version. We've got 2, which are addresses from these are two uint8 arrays. The nonce is just a number, I think that's an int64 or something, which is fine. But then it's this, which is gas. Is it gas limit 2, 4, yeah, gas limit, and then gas fee, gas premium are all underlying. I think they're token amounts, not token amounts, are they? They're big ints, I think. But any type that is a type alias of big int in Go will get serialized. Is getting serialized into a uint8 array. So we have to. I've got a function that I copied from the internet, and it converts from a big endian byte array into a big int. So we can quickly go and take a look at that. The function I got was from little endian, but then you can quite easily turn that into just reverse whatever's there. So that's interesting. So I also have a issue to we've got the issue. Here we go. Yeah, that's it. Fix CBOR serialization of big.Int. So we need to fix any instances where we need to serialize, but also deserialize. So we need to serialize big.Ints into big.Ints where they're actually going to be big.Ints in Goland into byte arrays, and deserialize byte arrays into big.Ints properly. And so this is really highlighting the fact that we don't, at the moment we're doing things, but there's no guarantee of any interop between stuff. So we really need the other end. And so this messages observer is kind of the first step towards that, in that this thing will listen for messages, and now that I'm getting messages from the mainnet network, we can build a VM to apply these messages, using we can build a runtime, can take mock runtime as a kind of base for implementing it, and obviously look at the Go runtime in Lotus. But then once we've got the messages, we can start applying them to the VM and check that what is coming out is the same, the state transition is correct. And also, I really want to start running the test vectors against this somehow. So it's becoming obvious that actually doing all of the actors might not be a good idea, because what I can do is I can craft we can use test vectors to craft some zero state, which only includes the actors that we have in the state tree, and then we can load that state tree and into, or we need some code that will do that. Read a car. I think we've got some car modules. The IPLD team have got some JS car modules, so we might be able to read a car and load it into the block store, and then yeah. So what I was thinking is use test vectors, create a test for, or tests that only include the actors that we have to check interop. Might be a good idea. Yes. So that's becoming increasingly more obvious, because if I go around and implement all of these actors and then I find something again like this with the CBOR serialization, then I'm going to have loads and loads of types that I'm going to have to change, like hundreds of types that I'm going to have to manually change the serialization and deserialization of big.Ints for, and that's not good. So ideally we want to know as soon as possible where we're breaking compatibility, so that we don't follow in the wrong footsteps. Okay, so what I'm doing today, I'll probably like stop before I actually do any code today. But I've got the actor, I've got the state. I'm just creating the so I've got one test, and that's passing. This is just a noddy test that we can do for all of the actors. Check the exports. There's a utility function for that, and then I'm just moving on to constructor tests. And I've just copied in the Go code here. But yeah, I literally got to this first line, and for most tests we have there's usually a test harness. Got one for the cron actor that I did already, but they've got some utility methods in there. So I'm just building the harness for the power actor. Got quite a lot of utility methods here. I mean, it's much bigger actor than the other ones that I've worked on so far. And I just got down to verify empty map, and then so I realized that this isn't being used just by this harness. So I've got a utility function that I'll be able to use in tests, and I've just got to the point where I'm collect keys is kind of map, because we've got a map here. We're gonna have to do like map.keys and then push them. Oh no, I've done it here. Here we go. Yeah, I've done it already. So that's that. That's cool. And then, oh, interesting. I don't need to convert it because I'm expecting it to be empty. Cool. Verify empty map. Of course, I'm expecting it to be empty. Push key. Okay. Well, actually, it doesn't matter the type of anything that goes in there because I'm expecting it to be empty. So there we go. Yeah, there won't be any error. It will throw if there's an error, and then I just want t dot is keys dot length 0. Just verify that there's nothing in there. Yep, never reassigned, that's fine. There we are. Don't need that anymore. Alright, so verify empty map, that now works. I should just be able to import that. Okay, wait a minute here. You need to have .js on imports in modules, and TypeScript defaults to not doing that when it automatically imports stuff. So that's annoying. Verify empty map. H. No, I just need T. Pass it T. Pass it the runtime and the claims, and that. And surely this is an async thing. Let's wait for that to happen. Great. so that's that one function down. Okay, so I'm going to move on to the next ones, and then eventually we'll get to the point where we've got the harness, and then I can get back to the constructor tests. Hopefully, if you look at specs actors, the tests for the power actor are grouped quite. I mean, there's just one file with like 1,300 lines in it. So anyway, but they've grouped them so test construction has multiple tests in it. So that's going to be a file. Test create. So this is like, create minor. It's going to be a file, or maybe part of. So update claimed power, this is going to be a file as well. But yeah, look, so they've got individual tests within this this kind of group. So they group them nicely, but not in separate files. So this is just one massive file where you can't understand it all. Anyway, so that's the idea. Going to keep chugging on with that. And I think that's all I'm going to say for today. But thanks for joining me. Until the next time. Bye-bye.